Hello everyone, this is Ari from pantechelearning. Is my voice is clear? Anyone in the chat box? And my screen is visible? Good evening, Sudhakar, good evening, Sunil, good evening, guys, Sabari, Raman Reddy, Lavanya, good evening, guys. Okay, so we will wait for the students to join, then we will get into the session. Okay, we will wait for 2 minutes. Supriya, good evening. Manisha, good evening. Ramesh sir, good evening. Good evening, guys. Good evening, all. So, in the previous session, we have developed the code for DMA using the direct memory access. So, we have already developed the code. So, today I will, in the previous session, they have said it is not clear. So, today I will give a quick recall of this, and we will, before that, we will upload the code to the discovery board and we will see the output. Okay. Okay, we will get into the class. Okay, before that, so something about Pantech. So our vision is to help 10 million students. Excuse me. So our vision is to help 10 million students to learn the technology in a easy way. So we are providing lots of projects. We are giving education equipments like for lab equipments, lot of things. So we have a specified labs of 12 labs. So we have an IoT lab, EV design, AI innovation, autonomous vehicle labs, brain computer interface labs, data science, embedded design labs. You can even get a PCB fabrication. We have a PCB fabrication lab. So even you can give us a design. You can get what is the design you need. Okay. So then we have a DSB and FPGA labs and UPN microcontroller labs and power electronics and drivers and renewable energy and design labs. So these are the areas where we are available. So guys, if you need any projects related to these things, means you can approach the Pantech elearning guys. So these are the laboratory projects. We have development kits we have given for the colleges. Okay, so for product inquiry you can use this mail ID sales@pantechmail.com, or you can use this contact number to make a direct conversation. Okay, so this is our address, which is where we are located. So this is our factory address. So as I said, we have 12 types of labs, and you will get the education equipments, components and sensors you can buy from here, and you can get an, if your project is good, and you can get an fund for the project support. Then you can have a technology transfer and for fast prototyping, and we are giving a LMS support for kids. Okay. So guys, so this masterclass is going to be converted into an internship. So you can now convert this masterclass into an internship. So this internship is on for 1 month on embedded systems. So we are going to add some advanced topics, and we are having a topics in a pipelines. So you can register this for a fees of 1200. So it is not 1200. You don't need to pay amount of 1200. So you will have a discount of 509 rupees. So use this code ESMC1, and the internship fees is 691 only. Okay. So guys, use this for registration. So the links will be provided in the chat box. So you can register that. Okay. So what are the benefits you are going to get? So you will get 30 days of live session recordings. It will be accessible for 90 days, and you are going to see an hands-on practice on embedded projects, and you are going to do some projects, and you will get 30 days of downloadable presentations. And the main advantage is we will have a 1-to-1 live session every Saturday. So this Saturday is going to be another live. So guys, register before so today the link will be provided in the chat box. So use those link to register for the masterclass and attend the Saturday's class. So don't miss this Saturday class. So from Monday the batch 2-3 is going to get started. So the discount will be reduced. So guys, you can see in chat box there is a payment link. Use this link. You will get after registration you will get an internship confirmation letter, and you will get 2 e-certificates. One is for participation and another one is for completion. Okay. So you can join 1 month of internship on embedded systems. Okay. So our registration fee is 1200. So you don't want to worry about the 1200. You can use this ASMC1 coupon code. You will get a discount of 509, and the discount fees is 691. So this is the link, guys. Use this link for the registration. Okay. So the link will be available in the chat box. So click those links to make a registration now, and try to attend the Saturday's live class. Okay guys. So today we will get into the code. Okay, we will get into the code. So this is the code we have developed yesterday. So we will today see the outputs. Okay. So So this by clicking this, it will upload the code to my board. Okay. So then I will go to the debug. So start the process. Okay. So you can start the process, and you can see I have connected the channel 1 with the 3.3 volt of supply and channel 0 with the ground. Okay. So that is what the reading is showing here as. So I will change the pins. You can see here, right? Callback stack. So we will change this. So you can see I have used this 12-bit resolution. So we have specified 12-bit resolution. So its sum of the value is 4095. So now I am connected the 3.3 volt to the channel 1, and I connected the ground to the channel 2. So I am getting this readings. Okay. So today what we are going to do is we will going to use the temperature sensor which is inside the board, which will be available inbuilt in this board, discovery board. So we will use those. We will use the temperature sensor as we will configure it as on channel 3, and we will develop a UART communication. Okay, between these. Okay. So before going to this, we have to configure the clock, because we are going to use the UART in the 16 megahertz. Okay. So we are going to use the in 16 megahertz. So we will set up the system clock as per the we will use the U sort of 3 and we will use the DMA 2. So DMA 2 is connected to the APB 2 bus and the U sort 3 is connected to the APB 1 bus. So I am going to give the frequency of 64 megahertz for the APB 2 bus and frequency of 16 megahertz for the APB 1 bus. Okay, so for that go to the Q by D. So I have selected the HSC clock as a main crystal and I have given this PLL and I have selected the 64 megahertz of clock and I am going to use the 16 megahertz for the pre-clock 1 and 64 megahertz for the P-clock. Okay, so these are the values we have to give the M and P value and we have to give the we don't need to specify the AHB prescaler value. We have to specify the AHB prescaler 1 and we don't need to specify the APB prescaler 2. Okay, so we will go with the code. Okay, so I think everyone will have a data sheet, guys. So I will for going to data sheets and showing it will be take lots of time. So this clock configuration alone I will develop. Okay, so I will say what are the things we are going to do. First we will enable the user 2. So before that we have to see as user 2. HB of ENR in this go to the APB 1 bus. This we have a user 3 here. Okay, we are going to configure this user 3 only. Why? Because we are already configured the PA1 and PA2 as an ADC pins, ADC channels. So we can't use those user 2. So we will go with the user 3. Okay, so I will send the logic 1 to the 18th bit to enable the clock. So this will enable my clock. Okay, so what is the next thing I have to do? Wait a second. Next thing is I have to tune on the HSC clock. Okay, so before this we have missed one step. What is the step we have missed here? Anyone in the chat box? What is the thing we have to do before tuning on the clock? So first is we have to give the power element. Okay, so we have to go to the APB1. In those 28th bit we will have as power clock enable. Okay, so what is the next thing we have to do? We have to tune on the HSC main crystal. Okay, so for that it will be in the control register. So RCC of control register of it will be in the 16th bit. Okay, so next is we have to check whether the HSC is selected or not, working or not. So go. We will create a while of left shift of 70. So this will check my HSC clock. Okay, then we have to tune on the PLL and we have to set the source, PLL source. So it is in the control register. So you can refer to the reference manual. Okay, so 24 which will tune on my PL. Okay, so next is we have to select the source. We have to give the source HSC as a PLL source. So for that go to the RCC of PLL configuration register in the on left shift off. It is in the 22nd bit. So we have selected the source. So now we have to give the M and N value. P is 2, so it will be in the reset state, no problem. So we have to give the M and N value. So M value is 4 and the N value is 64. Okay, so which we have already configured in the timer. For left shift of 0, this will set my m value and I have to set the n value 6. So this will set my n value. Then I have to check the PLL flag. Okay, so while off. It will be in the control register. (25th bit). Okay, so I am going to wait till this bit is get set up. Okay, so next is we have to configure the PLL as a system clock. So for that, go to the RCC of CF configuration register. In that, we are going to send the file to the first bit. So this will set my PLL as a system clock. What is the next step I have to do? I don't want to give an AHB 1 value and APB 2 value. I just want to give the APB 1 prescaler value. So it is divided by 5. So divided by 5 means, it is divided by 4. So we have to go to the it is divided by 4, so it will be 1, 2, 4, so it is 1 plus 4, it is 5, so we have to left shift the 5 to the 10th bit. Okay, so this will set my AHB prescaler value, APB prescaler value. Okay, then I have to wait till this PLL is selected as a system. Okay, so it will give a flag in the RCC of configuration register in the on left shift of 3. Okay, so this will check my. Now we have created the system clock. Okay, so now next thing we are going to create is we are going to create a UART communication. Okay, so we are going to read some. We are going to see the some values in the serial monitor. So for that purpose, we have already configured 16. We are going to use the UART in the 16 megahertz of frequency. So we will go get into it. Okay, so void of init UART. So now, what is the first step we have to do? We have to enable the UART of 3. Okay, so go to the in this we have a UART in the 18th bit. So we will left shift the logic 1 to the so this will enable my clock for the UART 3. Okay, so next is we have to enable the clock for the GPA port. So first, before that, we have to know which port it is connected to. So go to the data sheet. In this you can see we have a PB10 as a UART 3 of TX, and we have a 11 as a UART 3 of RX. So we are going to configure these two pins. Okay, so go to the GPIO. So before that, we have to tune on the clock for the GPIO B. Okay, port B. So go to the HB. In this, we have to send the logic 1 to the first bit and go to the motor register. In this, we have to configure the pin 10 and 11. Okay, so we will set the alternate function in these pins. Okay, so first RCC of H B on left shift of 1. So this will enable the clock for the GPIO of B. Okay. So next is we have to select the molar function. Okay. So GPIO B of molar. So I will simply left shift the 2 to the 20 and 2 to the 22. So this will set alternate function for my pins 10 and 11. Okay. So next is we have to set the alternate function. So it will be in the we are configuring this pin 10 and 11. So it will be in the I register, right? So go to the data sheet before configuring. User 3 is in the AF7. So alternate function 7. So go to the in this 7 is 1 plus 2 plus 4, it is also 7. So we have to left shift the 7 to the 11th and 10th. Okay, pins. So 8 and 12. Okay. So I will left shift the 7 to the 8 and 12. Okay. So this will set my pins for the alternate function. Then we have to set the baud rate. So while in UART communication class, I have already shown you how to set the baud rate. Then we have already derived the baud rate for 16 MHz at oversampling of 16. Okay. So now I will set the baud rate. So use sort of 3 of BRR. So is equal to 0.0 cross 063. So this is the baud rate for 16 MHz. So it will be in the 9600 baud rate. Then we have to enable the TE and RE pins. Okay. So go to the so it will be in the control register bit 2 and 3. Okay. So out of 3 is equal to CR of 1 is equal to one left shift of 3 and one left shift of 2. So this will enable my TE and RE. Okay, receiver enable and transmitter enable. Finally, we have to enable the UART. Okay, for that use 3 of CR of 1 left shift of 5. Okay. Next thing we have to do is we have to enable the interrupts. So TXCIE and RXCIE. Okay. So we will enable those interrupts. 5. This will enable my interrupt TXE and this will enable my RX. Okay. So now we have finished the UART's initialization. Okay. Next is we have to create the write function, right? So going to create a write function. Void of so in this I will send my data to the user of so to the data register. So I will send this. So now I have to wait till the data register bit to get empty to set. Okay, so while off, it will be in the status register. In 7th bit. So we will wait till this bit is get set. Okay. Next is we are going to create a string function. So if you want to send some value or send some string directly without using notation, so for that we will create a function void of print of character. We will use the pointer. Okay, so msg. So what is the first thing is we are going to create a for loop. Okay, int of I is equal to 0. So next is get. Next is I is going to greater than the my string length of my message. Okay, then I of plus plus. This is my condition. Then I will open the loop. Okay, so to eliminate this error, we have to include the because the str length function is in the hash include of std. So it will be in this library. Okay. So next is we have to create this. We are going to. So next is we are going to create this y. So we are going to wait for the txe bit. So the same procedure. So we are going to wait till this bit is get set. Then I am going to send the value to my write function. Okay. So now we have created the print function. Okay, so go copy. Okay, so add the string. Okay, string dot h and now we have created the function. Okay, so what is the next step we are going to do? So we have already configured the ADC clock GPIO, then we have used the CRR as an 64 for we are going to use the ADC for at the 8 MHz of frequency. So we have set the resolution. This is I will explain this code. So we have already set the resolution as 8-bit and we have enabled the continuous conversion and end of the conversion, and we have aligned the right. We have choose the right element. We have to choose left element or right element. I have choose this right element. Then we have selected the channel. We are doing conversion in two channels, channel 1 and channel 2. So for that I have given the two channel of conversion. So I am going to use two channels. So what is the now I am going to do is I am going to add the temperature sensor. Okay. So go to the reference manual. In this you can go to the ADC. So in ADC you can see we have a temperature. So we have an inbuilt temperature sensor here in the channel 16. Okay, so ADC of channel 16. So we have to configure this channel also. Okay. So first we will say how many channels we are going to use. So I will simply send 2. So this will say I am going to use the 3 channels of conversion. Then we have already selected the channel 1 and channel 2 as an analog mode. So we no need to select the channel 16 because the channel 16 is not for the pin outs. It is dedicatedly for the temperature sensor which is inbuilt. Okay. So we don't need to set the mode up. The pin will be not available. Then we are going to give the sampling time. We have already set the sampling time for the channel 1 and channel 2. Okay. So now we have to set the sampling time for this temperature sensor. Okay. So before that you have to go to the data sheet and you have to see what is the minimum sampling time it is working on. So it is the minimum sampling time is 10 microseconds. So I have to give more than 10 microseconds of sampling time. Okay. So now I will go to the registers in this. Go to the ADC off. So in this SM prescaler 1, in prescaler 1 you can see we have a channel 16 here. So we are going to use this 84 cycles. So it will generate a sampling time of 12 microseconds. So the minimum seconds required is 10 microseconds. So we will operate in the 12 microseconds. Okay. So we will send this is 1 to 4. So we will send the logic 4 to the 16th, 18th bit. Okay. So go to the ADC off. This I want to send the 4 to the 18th position. So this will set my sampling time for the as 12 microseconds. Okay. Then we have to tune on the temperature sensor. Okay, we have to give the input to the temperature sensor. So for that go to the CCR in ADC. You can see we have 23 bit as a temperature sensor enabled. Okay, so we have to send the logic 1 to this bit. Okay. Okay. So we will say ADC off. ADC off. So this will tune on my temperature sensor. Then we have already configured we have enabled the DMA and continuous request. Then what is the next thing we have to do is we have to select the sequence. So we have to, for channel 16 we have to say the sequence. Okay. So go to the sequence register. So in SQR so in this I will send the channel number to the sequence of 4. Okay. So I will we will send it to the sequence of 3. So we have already sent the channel 1 to the sequence 1 and sequence 2 as a channel 2. So now I am going to send this channel 16 for this 10th sequence. So it is the order which is going to work. So ADC off, on off, yes, Q off 3. So I am going to send the 16th channel to the 10th. sequence of 3. So now we have configured the init ADC. So we have already created the ADC of enable. Then we have to do some. We have already created the DMA init function. So we have enabled the DMA clock. Then we have disabled the DMA. So we should not enable the DMA before this setting these values. Okay. So I have disabled the DMA. Then I have selected the circular mode. Then I have given the memory increment. Then I have set the size for data size and memory size. Okay. Then I have selected the channel for streaming. So I have selected the channel 2. Then we have an ADC start condition. Then we will finally come with the configuration. This is the size, which will store the size, and pairs, which will say the source address, and memory address we will set it in the MO0 of ER. Then we will enable the DMA. Okay. So we have created these functions. So we have already RX data. So we are reading 3 channels. So I will give the size of 3. So before this, we have to go to the ADC of temperature sensor. You have to see some characteristics. So we have a formula here for calculating this temperature sensor. So copy this and paste it here. So what are the things we have to give is in vsense we have to say the value. So our reference voltage is 3.3, multiply it with Rx of in which data my temperature value is storing. So it will be storing in the third portion. Okay. So I will mention it as 2. Then I have to divide it by 0.95. Okay. So next thing I have to do is we have to know the V of 25. Okay. So for that you have to go to the data sheet. So in data sheet you can see we have a V25 voltage at 25 degrees Celsius. It is 0.76. So we have to give this value 0.76. Then you have to say the average slope. Okay. So go to the. So we have an average slope of 2.5 volt. So we have to convert it into the millivolt. So we have to convert it into the voltage. So the value will be 0.0025. Okay. So then now we have completed the code. Okay. So now we will build this. So we have an error. So we have to give here we have to mention the float. Okay. So to give a float. You have to mention here also float. Okay. So you have to will initialize the UART. We'll create a float here. Float of we will take this, then we have somewhat someone okay. So we have a 0 errors now. So now we will upload this code. Okay. So now we will upload this code. Okay. So you will see the debug output. Okay. First we will take this and so we have already declared the data. Okay. So now we will so wait a second guys, so I will, so it is same code, wait. So you can see I have connected the 3.3 volt to the channel 0 and ground to the channel 1. So this channel 2 is this RxD of 2 is storing the value from the reading from the temperature sensor. So we have some calculation error here. So this is how we will configure the DMA with the ADC, and we will configure the internal sensor. So in tomorrow's class we will rectify this sum of the error. Okay, so in next class I will show you the rectify the sum of the error, and we will use the UART to print the data in the serial monitor. Okay, so guys, today's class is over, so we will meet on tomorrow. Okay. Okay, so I will end this session now. Okay, so in tomorrow class we will see the temperature sensor output, and we will take the values in the serial monitor. Okay.